Okay. All right, start over. So accident brief, man pinned and killed by a cut tree. A man was killed March 26, 2020 in Lorain, New York. When a tree he was cutting down on his property fell on top of him, state police responded to the residence. Found Patrick D. Bates, 57, pinned underneath a 60-foot tree. Bates was declared dead at the scene. An investigation revealed that Bates had been cutting the tree down with a chainsaw when the tree kicked back towards him, struck him and pinned him underneath, according to a report by the Post Standard. So this one really ties into what we're going to be talking about today, about having escape routes, knowing where the danger zones are when we're felling a tree. And second one, climber injured after tree fails. A climber suffered serious injuries November 2nd, 2020 in Mystic, Connecticut after falling 50 feet when the tree he was cutting failed. The victim, a 25-year-old man who was a contractor, was in the process of limbing and topping the tree for removal. The man had just cut the top off the tree when the tree snapped 30 feet below him. He landed on a small shed type structure and was trapped there. Under the toppled tree, firefighters worked to pull the tree off the climber and extracted him from the shed. The man was flown to LifeStar and Hartford hospitals in serious condition. So this one's super important. I'm guessing the person was in a hazardous tree. A lot of these accident briefs are from reports in the news, so they don't give you too much detail of what happened. But seeing this one, and we'll talk about the reactive forces when felling. If you're taking a top off of a tree, especially a large one, using a conventional notch, the tree, when you take the top out, it'll actually push back on the stem of the tree and push the stem back, and it'll kind of bend it in a sense. You can just, that's not even rigging it, just, blowing the top off, especially if it's a larger top. If there's a defect below you, you got to be cognizant of that. Or if the tree's dead and unstable, they can actually, cause the entire stem to fail at the root plate, or like in this case, snapped 30 feet below them on the tree. So doing those site inspections is really crucial. And this one was actually pretty recent. February 25th, 2021 in Brownsville, Tennessee, a bucket operator died when his chainsaw kicked back into his neck. And an eyewitness said he was cutting a branch one-handed with his left hand. The branch was just above his head, and he turned to throw the cut branch. The saw glanced off the tree limb and kicked back, striking the victim. He slumped down in the bucket. By the time coworkers were able to lower the victim and extract him from the bucket, it took 4 people, a forklift, and a rope to do so. He explained he had expired. So going back to it, especially in my chainsaw basics talk a couple weeks ago, don't be one-handing a chainsaw. And this seems like, if you can read that, he was cutting a branch above the person's head. So they were outside of their power zone. Like I talked about, working our power zones, about from your chest, up chest to thighs. I'm staying within that area. You're going to have more control, especially with 2 hands. If you're cutting with 2 hands above that area, you're going to have less control of the saw if you do occur kickback in the process. This really just shows also you have to be very speedy in these situations. Like it took them a forklift to hoist the person out of the bucket to even start doing any sort of first aid to the victim. So having our plan in place to be able to get someone out of a bucket if they do get into a situation like that, like, dead weight is really, really heavy and hard to move. So I know our buckets, we do have a pin that you can actually tilt the bucket if need be to extract the victim out of it and clean it. And just knowing how to lower the bucket, like on your crew sites, if someone does get injured, the time, it doesn't take long for someone to bleed out. So being on your toes, checking in with your bucket operators and stuff like that, if you're a ground worker, making sure everything's good. So if you do have to lower them out, you can get first aid to them quickly. All right, so 6 steps of tree felling. What's up here? So first step is inspection. There's 2 different inspections. We have the tree inspection And then we have a site inspection that goes with it. So tree inspection. So I'm just gonna read through this. Every tree felling event presents hazards that should be identified before work is started. The first thing you must do after the pre-job briefing is assure the work will be completed without injury or property damage, is to inspect the tree and work area. The tree inspection process will help you establish a step-by-step plan to identify and eliminate hazards. Make sure that everyone on the crew is aware of all the hazards that exist and how to safely work to eliminate the hazards. So when we start with our tree inspection, we want to start at the base of the tree and work our way up. So we're looking at the roots. So start the roots. What we're looking for is look for decay, look for like armillaria, root rot, because if we're going to have to pull the tree over itself, we need to make sure that the root plate is intact enough to actually put those forces on the tree. So we don't just make the entire tree fail below our notch that we're just like that person that fell. There's a lot of forces, even just, doing a notch and back cut. But if we're actually going to be writing a tree, it has to have a root plate that can actually withstand that. And we're also going to look for roots that are upheaved from like wind or storms. A tree that's leaning, it might have grown that way. A good way to know if a tree is leaning because of damage to the roots. On the opposite side of the lean, you'll see a mounding section of it where the roots actually broke and lifted out of the ground. They might not be exposed out of the ground. They'll just be lifted up. You'll see this kind of dirt mounding on the backside of that lean. And then working up the trunk, we're going to want to sound the tree for hollows. You can get a sounding hammer like this, or you can use the backside of a axe handle to do that. You'll get pretty similar results. The rubber mallets are better for if you're not going to be doing like a removal on the tree, because it won't damage the bark as much as like hitting it with back of an axe or just a handle. So when you're sounding a tree, what kind of sounds are we looking for? Can anyone explain?
Like a muddled sound, like a not solid. To me, it kind of, you hear this hollowish kind of like noise with inside of the tree versus it just bouncing back hard at you.
Yep. So there's like three kind of different sounds that you'll hear. You'll get, if it's a solid tree, healthy tree, you'll get kind of a higher pitched sound because it's nice wood. It won't resonate very long. If it's a hollow tree, it'll sound almost kind of like a drum. The larger the hollow, the deeper the tone will be, and it'll resonate longer because the waveforms can move farther through that space there. And then the third one would be if it's a really dead sound, where it doesn't produce very much sound at all. It's going to be kind of like hitting something that's super soft, and you might then have more decay. And why would we want to sound a tree before we put a notch into it?
Because if it's decay, there's a chance it could fail even when you're notching it if it's just punky inside and not necessarily hollow.
Yeah, exactly. Or in the case that if it's hollow, we might not be able to fell that tree. If it's a large, say it's like a large red oak, and we need a laid in a certain direction, maybe against its lean or something, and we sound it and we're like, this sounds really hollow. We might not have any hinge wood. It might only be like trees can still grow with about 10% of their wood around the entire trunk. So if we have only 10%, we're notching in a third into the tree. We're not going to have any hinge wood left. We might have barely any hinge wood on the outside of it. So we might have to take an account to remove that tree in a different way before we put that notch into it. Because we put a notch into it and it's hollow, we're going to have to devise a new plan. And then that situation just got a lot more dangerous. So just taking the small step to kind of it's not going to be perfect, obviously, but it'll give you some kind of clue to what's inside the tree. And then working your way up the tree, we're going to be looking for cavities in it. We're going to be looking for cracks and splits. So if it was like a storm tree, maybe an inclusion, it may be split down from the main inclusion. Now it's split down the tree slightly, looking for those cracking that might not look like it's too terrible, but we might want to be able to brace both those before we fell it. So if we just notch it and it's actually fully separated after we cut our notch in there, half the tree could fall a totally opposite direction, most likely towards the weight. We're also looking for large deadwood, stuff that can get dislodged. So large deadwood and hangers in that tree, because the most dangerous place is within 15 feet of the stump of the tree that you're cutting. So if you do have hangers, like large hangers in the tree, you might want to extract those out of the tree before you go and fell it, because those could actually become projectiles also and be thrown, because there's a lot of energy coming, a lot of stored up potential energy in a tree standing there. And once you get that thing moving, it might throw some of that dead wood. Some of that larger dead wood might break and explode. So you might want to take that stuff out if you're working in more of a tight area. And we're looking for embedded objects. So a lot of urban trees will have like nails in them. We all hit nails with our chainsaws. Bird feeder hangers, might be a fence post, might be even almost all the way grown into the tree. You know, maybe it's just a volunteer. They had a fence post there, or it was an old stake. I've seen that quite often where they stake the tree with a metal post and they just left it there. And now the tree pretty much almost grew all the way around it. You know, we got to look for, you know, fences and stuff like that, or any other object that might be embedded in the tree that's going to prevent us from making our back cut and notch. And then when we're doing our inspection, we got to check the height. Why would we want to check the height? There's a couple different reasons. There's one obvious reason.
Make sure we don't hit anything.
Yeah, make sure the tree will fit where we want to fell it. That's pretty basic, right? If we don't know the height of it, we also don't know where the danger and safe zones are. And we'll get into what those mean. But this is the first thing that we're going to want to look for. You know, well, we got this tree that we need to remove. Maybe we can fit it. You know, if we know we can check the height to an approximation, we're going to have a better idea. You know, if we need to take the head out of it first before we fell the stem. An easy way to do that, you can use this with your rake handle. All you need to have something in your hand that's long enough and straight that when you hold your hand straight out, camera a little bit, that your fist is going to be looking down at where you're going to notch, or if you're doing the whole tree, would be at the base. And then that piece of wood could be a stick, could be a rake handle. So your rake handle could be below your hand too, where you're gripping it. And the back of the rake handle goes to your eye. And once you stand it up, you're going to make an equilateral triangle. And when you move back and forth walking, you'll look up the stick. And then once the stick and the top of the tree meet, that's where the tree is most likely going to land, you know, approximation. And then we also need to check the lean of the tree. So checking the lean, this is a super easy way to do it. Obviously this is all approximation that we're working with. Say if my head is the canopy of the tree, I'd put my hands on either side of it. So my left hand on the left side of the tree, my right hand on the right hand side of the tree, and then I'll move my hand to the center and draw a straight line down. So you can see drawing that straight line down, the center of mass is off the center of my neck. So if my neck was a stem. So in this picture, the amount of lean is about 3 feet off the stem of the tree. That'll be important because we'll take that site of lean from the direction of fall we want in the first picture. Then the second picture, we'll see where we want the tree to land, but the crown is 3 feet off to the left of it. So we are actually going to need to aim our notch 3 feet to the right to make that tree land in the intended area that we want that target. Then we're also going to want to do a 90-degree to where we're going to want to fell the tree, the direction of fall. And we're going to be taking our sighting the same way to sight back and forward lean. Why is it important to know back and forward lean? What are some of the hazards?
Barber chair.
Barber chair, yeah, you have a heavy forward leaning tree, you might think like, super easy. That's the way I want to take it. But if there's a lot of weight and you're not doing a proper back cut, that you might have to chase the cut. And if your chainsaw is dull and it's too big of a tree, you could potentially have a barber chair. And a barber chair, you'll have a delamination off the back of the tree and it'll actually fold and then seek the stump and come back at you. A true barber chair. When they're really wet, sappy wood. Also, if it's a heavy back leaning and we want to take it over its lean, we might need to be thinking of what kind of notch we're going to be putting in there. Say if we have a tree that has a back lean about 30 degrees, maybe 40 degrees, pretty heavy back lean, that's crazy back lean, but we're going to use machines, mechanical advantage, we're going to pull it up. We're not going to want to do a conventional notch. Can anyone explain me why we wouldn't want to do a conventional notch on a heavy back lean?
What, a twist on you?
Good twist on you. Yep. What's going to happen to that notch when you're pulling it up? When does that notch close?
Before you reach center of gravity.
Mm-hmm. Exactly. So a conventional notch, if you're doing a 45 degree, we'll get into notches a little bit later. You do a 45-degree angle with your bottom shelf flat with the earth. That's going to close at 45 degrees. So if your tree is leaning back and you're pulling that up, that could actually close. The notch could close while that tree is standing straight up. Now that tree is going to go whatever direction it has the weight, and with gravity. So then that's why it's important to know those factors before we choose our notch in our plan. So we would want to do a more of an open face, maybe a 70 to 90 degree, so we can get more pull on that hinge, so it's longer for that notch to close.
Another thing with head leaners, with choosing your notch, is you don't want to make a super deep notch with a head lean because there's a good chance your saw is going to get stuck before you can actually make your notch. So trying to make more of a shallow notch on those, so, at least to start off with, and then you can work it in if you're not in far enough.
Yep.
But taking your time in those and not just boring full in. There's a good chance. I've gotten plenty of saws stuck doing that.
Yeah, like little trees and stuff. There's like
Yep.
So the second part of our inspection would be our site inspection. I got to turn off my volume for a second. There we go. All right, our site inspection. So we got to identify all the hazards and targets. Move anything that we can out of the way. We're gonna have to site up the area. Like, can we fit this tree where we want to put it, or do we have to do a different plan? We're also in the site inspection. We're going to be inspecting the escape route and base of the tree. We're going to be looking for brush, limbs, and other trip hazards within and around the base of the tree. We're going to be looking for foreign objects, so like fences, stakes. Sometimes when we're working kind of like maybe in Chaska, some of those wood areas, there could be old fencing, that we don't really see. It's all tangled up with the bramble and like raspberry bushes under there. Making sure we have a clear area where we can escape to, because if we don't, we're going to need to set up a different back cut process. And then we're going to be looking at the condition of the ground and terrain. So is it muddy or icy? Right now, maybe not today so much, but the last couple of days, it's been very, very slick out. So we got to know if we have good footing so we can escape out of the area. And then we're looking at slope also. You're most likely going to want to be on the uphill side while you're doing your back cut, because when trees come down to the ground, they're going to want to roll downhill down with gravity. Also in the site inspection, especially if we're working out maybe more in a wooded area and we're felling trees, we're going to check if there's nearby dead standing trees or large dead overhead limbs or other hangers in adjacent trees. You can easily, if you're brushing a larger tree through, say if it's like a Dutch elm disease tree, it's dead and it's on the woods, and we're just putting it on the ground, super easy. But there's other dead, smaller trees around there. Those could hit and those can come back at you. Same with limbs overhead, like dead ones that could hook on there, break them, and those could fall towards you or fall towards your team that's pulling on the rope. And we're also going to be checking for overhead conductors, utilities in the felling and danger zones. The last thing we want is put a tree onto a primary or take out a service line. We're also going to want to check for vines on the tree, might not just be the trunk of the tree. You might want to inspect if there's grapevines from another tree coming over into the canopy of the tree that you need to fell. Grapevines can be very, very strong, and it can hold that tree up and then pull it in a totally different direction that you were expecting. I have one quick story. When I was working for Davey, I didn't do a total 360-degree walk around. It was like a 12-inch spruce tree, Colorado blue spruce tree that they just didn't want in their landscape anymore. They had 3 other ones. All this nice landscaping. We had a big drop zone that was going to just pull the tree over into it. Limbed it up about belly height, just to get under there to put a notch in it. When I went and did my back cut and had my team pulling it, the tree started going and then turned and went totally sideways and crushed their logelias and their dogwoods and broke some other landscaping things. And what we found was, since I didn't do a 360 on the entire tree, there was actually a line attached to another spruce tree in that row that they're using as a guy wire. If I would have just done a 360 on that, I would have ran into it. Since it was such, like, these spruces were so close together that you couldn't visually see it from the outside. So that's why it's super important. Like, I was dumbfounded why this tree just went sideways on me. But that's the reason it's super important to do those 360s on those trees, because there was even just a little thing that you think like a homeowner, why would you attach these 2 trees together? Homeowners do some silly things. Also, in our site inspection, we want to look for other like tree stumps in the felling area where we're going to lay the tree, large rocks, and uneven terrain. Once the tree is released from the hinge, that's coming down at a pretty fast clip, and hitting any of these objects can make the tree roll unpredictably. If we do have some sort of like terrain, like a slope or something, we might need to be attaching the butt to another tree or to the stump itself to hold it in place while it comes to the ground and comes to rest. We also want to look for sidewalks, driveways, irrigation boxes. Even with your pre-job, you might have seen irrigation boxes, but some irrigation boxes can be a little hidden, recessed, especially if they have kind of longer grass. So making sure we don't hit a valve box that can destroy their irrigation system, flood their yard, especially if you don't notice it. It could just be leaking, and then they'll have a flooded yard later on. Sidewalks itself, can we put this tree down over the sidewalk? Are we going to need to crib it over the sidewalk area? Same with driveways. You might be like, oh, I got to shorten this tree up. I'm going to take the top out, and now we can fell the spar, which is towards the driveway. But now that spar doesn't have all that cushion with the crown of the tree. That might not be a great option, because sticking a spar into pavement or concrete is probably going to break it. So we're going to take all these things into account if we can actually fell that tree in that area. Any questions on site inspection? Any other comments?
One thing when you're talking about like felling in wood areas, looking at other trees, dead ones that could potentially turn into projectiles. Another thing that, and maybe you'll get into it, is, even live trees, when you're in wooded areas, because if you don't have a proper fell zone, you could create a bunch of springboards, which would just create more hazard. Yeah,
that's a good point. Actually, I totally blew over that in my notes. Felling a tree into another tree is super hazardous. Try to avoid it at all costs. If you get a tree hung up, it makes the situation way more dangerous than if you had a rope in the tree and we're pulling it into an open area. So step 2, we got to go through a job briefing again. So we already did our pre-job brief, and now we're getting to the point of we're going to take down a spar. We already removed most of the tree, or we're to the part of the job where we're going to start felling some of these trees. We're going to want to redo a job briefing. We're going to re-identify all the hazards associated with the felling process of it. So this is more identified just in the felling process of it. We're going to communicate to the crew members and their individual work procedures. So what they're doing in the process. So we don't have workers from the front yard coming into the backyard while we're taking the tree down. So everyone's on the same page, knows what's going on and what their role is. We're going to inform this crew of any special precautions necessary to complete the job. We're going to ensure that the proper personal protective equipment is being used. Make sure we have chaps, hearing protection, our helmet, our clip on our helmet is clipped. We have our safety glasses. We're going to explain lines of communication, review signaling and communication procedures. This is super important, especially if you're pulling over with any machinery or any mechanical advantage where you're pre-tensioning lines. It's very, very easy, even with small equipment, to over tension your pull lines. I prefer using mechanical advantage over using a machine to do it. Making sure everyone's on the same page of what signals you're going to be giving them as a sawyer for when you want them to increase the pull, and then maybe talk about how much pull at a time, especially if you're using machinery. So it's really good to have, especially stop. I always have closed fist as a stop everything, what you're doing, because a lot of times you're not going to be in a verbal communication at that point, because the person on pulling the rope should be 1.5 times away from the tree. So you might be pretty far away, especially if it's a taller tree. So having those hand signals. And then we're going to supervise and communicate. So the crew leader shall designate someone else to supervise the crew. If any reason, the crew leader must leave the work site or assume another function in the felling process. So that crew leader, if they become the sawyer, we need to designate someone else to be a lookout and supervise everyone else on the crew while we're doing the notching and back cut process. So everyone's on the same page, everyone knows what's going on with that, because you can't really be a great supervisor if you're the one doing the felling process. Everyone on the crew should identify hazards when they are spotted. This kind of teamwork will help keep everyone free from injury. Ensure that spotters are informed of lookout situations. So if we're working in more densely pedestrian driven areas, or we're working on larger sites with more teammates out there, maybe a commercial site, we want to inform or have lookouts so people don't come into the danger zones of when we're felling that tree. It's really easy. We've had incidences in our industry where people from the backyard walked to the front yard or vice versa, and then they were hit by the falling tree because the crew didn't set up a spotter to keep people from coming around the area. And it could be also, we've killed people where it's like pedestrians or homeowners that just walk, out their door and then just walk right into our felling area. So making sure we have spotters in those areas to keep people safe and out of our danger zones. And if anyone sees about to make a mistake, do something careless or risky, tell them about it immediately. Have an all stop on the situation. Maybe their notch isn't lined up where they think it is and they're about to do their back cut. Make sure you stop it, get that corrected. And then crew leaders should monitor crew members for sign of fatigue. So if you're a crew leader, you had a climber up there doing a big removal all day, it's hot out, they might not be the best person to come down and then fell the tree. Put someone else that's capable of doing it in that position. If you're fatigued, you're more likely to make mistakes, especially if it's later in the day and you just want to get the day done. Put someone that's more fresh to do that process. Maybe just have that climber be a lookout, give them a little bit of a break. All right, so step 4, we got to identify our escape routes. So the arrow pointing out, it's going to be a direction of fall of the tree. Then there'll be a 45 degrees off center of that fall of the tree. On either side will be your escape route. And then right behind the tree is also a danger zone. So this is another picture of it. We have our danger zone out in the 180 degrees. in front of the tree, 45 degrees off the back is going to be, we're going to choose one or either of the sides to be doing our back cut. And then the danger zone behind. We don't want to be on the left side and go, oh shit, this is not a good escape route, and then cross through that danger zone to escape out the other side. That is not acceptable. We got to make sure the escape route we are choosing on our back cut is going to be an escape route we're sticking to while we're doing the felling process. So choosing an escape route, it has to be unobstructed. We can't have, brush or bramble or fences in our way where we can't be hopping fences. It has to be an escape route we can walk at a decent pace away from the tree. It needs to be clear of trip hazards. The uphill side, if applicable, an adequate retreat path length, so at least 20 feet. Like Tom Ball's presentation is 520 rule. Tree takes 5 seconds to hit the ground. An average person can walk 20 feet in 5 seconds, so be 20 feet or more away from the tree. And then we want to look for overhead hazards that might be in our escape route. We might not want to be escaping towards power lines. If we have a situation where we have power lines kind of an L shape around the house, if we retreat and we're going underneath one side of those power lines, and that tree does turn for its worst and then hits the power lines farther out, that could shake the whole system, and the whole system could fail onto you. So you got to make sure what side you're choosing is going to be an adequate escape route. If you are in a situation where you're in a tight quarters area, we can set up, and this is only going to be shown in the field, set up bore cuts with triggers where the tree isn't moving. You trigger, you can escape very, very far away from the tree before the crew triggers the tree and pulls it over. All right, step 5. Time I got. So danger zones. So our danger zone, everyone says it's 1 times the height of the tree, right? Really, it's 1.5 times the height of the tree. It's your danger zone. Anywhere within 1.5 times the height of the tree is really your danger zone. Your rope pulling zone is outside of that 1.5 times. So the dark bubble is 1 times, the blue ring is 1.5, and then the outer ring is 2 times. Then your watch zone is 2 times the height of the tree. Why do we have a rope pullers and watchers so far away from the tree?
Things could get thrown when you fell a tree, it hits the ground, it's a dead tree, shatter off a big limb, big piece of dead wood comes flying way out of the tree, it hits a rock on the ground, that rock comes flying out, hits somebody in the head who's just watching by. They're that 1.5 times away from the tree, could easily hit them.
Yep.
Something like that.
Exactly. If we have homeowners that want to watch, I want them well beyond 2 times away from the tree. And if that puts them in where they can't see, that's too bad. They can go inside their house. We're not here to put on a show for them. We're here to keep everyone safe. So just be conscious of some homeowners might be a little hurt that they can't see the process, but just let them know that it's safer for them to be inside their home or 3 times, 4 times away from that tree while we're felling it, because things can get thrown very far. All right, so pulling a tree over with the rope. So all trees with 5-inch diameter breast height or larger must have a rope used to start the direction of fall if there's a potential of causing property damage or there are hazards within 1.5 times the height of the tree. So in our case, that's going to be quite often. Probably 90% of the trees that we take down are going to have hazards within 1.5 times the height of the tree. And this isn't something that we just made up at Rainbow. This is an ANC standard. It is a should, not a shall, but that means it's recommended, and we will do what is recommended by ANC. So 8.67, a rope should be attached to all trees and stems greater than 5 inches in diameter at breast height, being felled to provide stabilization or directional pull where assisted directional felling is required. And that's really key, where directional felling is required. That is pretty much 100% of the time we're doing any felling, we need directional felling is required. not hitting something. All right, notch and back cut. So I'm gonna show this one picture, kind of go over a little bit, and then I'm gonna show a 10-minute video about Husqvarna. He does a really good job explaining this, a lot better than what a PowerPoint would do. So your notch, this is just conventional, would be a third of the diameter into the tree at breast height or wherever it is in your power zone. Your back cut would be elevated by 2 inches. Your hinge wood itself, the length of the hinge wood would be 80% of the diameter of the tree. So that's outside the center. So it's more in the sapwood area. And yeah, so I'm going to show the video because I think he explains it very, very well. Let me stop sharing here. Share the video.
I want to talk a little bit about notches. Now, I've drawn 3 pictures of notches on the board here. Why do you put a notch in a tree? For direction. Essentially, it's the direction of where you want the tree to fell. We have got felling marks or black lines on the saw or lines embossed in the saw all around the saw, such that if I want the tree to fall right up the middle, it starts by aiming your felling lines where you want the tree to go, if you will. That starts the first part of a notch, if you will, is direction. Do you understand this statement? If I say the notch is the front line of the hinge, do you understand what that means? Because if I've got a tree here and I have no attachment, if you will, to it, and the tree is leaning to the left a little bit, it invariably is going to go to the left, or leaning to the right, invariably could go to the right if I don't have an attachment point, like my elbow, to draw it exactly where I want it to go. So it's important that you understand that a notch alone is not, you're not complete. You need to have a notch and a hinge. Now, this first notch here is what you typically refer to as a standard, common, or conventional notch. It starts with a top cut into the wood about a third of the way, if you will, at a 45-degree angle. You then make the bottom cut. As a rule of thumb, you make the bottom cut with the lay of the land. In other words, this is on flat ground, if you will. This might be on steep terrain or hillside, if you will. So a minimum of 45 degrees. You want to cut this notch and create what's called a clean apex. You do not want to bypass the cut. In other words, where the top and bottom cut come together, that is the apex. That needs to be very clean and precise. You don't want to have the saw run underneath and create a bypass like that. You have to then go back in and clean that up so it's clean where both cuts come together, if you will. Now, I'm not a big fan of the standard conventional notch for cutting on the ground, because essentially what happens is the tree gets to 45 degrees, and then what happens to my notch? Yeah, the notch closes, okay? So when it closes, it puts pressure on the stump or the stem, and it tends to seek the stump, and you can see you get a lot of butt rebound or a lot of the butt end of the tree coming back off behind the stump. So rule 101 is never stand behind the tree when you're felling the tree. So to help you with this notch closing, because you don't want that tree to break at 45 degrees, because then it's going to go in the direction of the lean. It's not going to end up going where you want it to go, or it's going to sweep off the back of the stump, and that's not a good situation either. So what you want to do when you're making your back cut or your felling cut is you want to make this back cut from the back 1 inch to 2 inches above the apex, because that creates a stair step, or what we call a stump shot, so that as the tree is going, it tends to push on the back of this stump, and it keeps motion of the tree going forward. Very simple, the right thing to do. This is a Humboldt notch. It's a 45-degree standard notch upside down. It was developed in Humboldt County, California, primarily because of very steep slopes and felling trees on steep slopes. The other advantage of this when you're cutting big trees in Humboldt County, California, is that the notchwood on this conventional standard notch just sits on the shelf, and there was as much work, could be as much work getting that notchwood out. Those notches weighed 800 pounds, some of them, and up. So they made this upside down so that the notch would just slide out of the cut and you didn't have to deal with all that extra work. Now the same rule applies, though I'm not as big a fan of this, is because the tree at 45 degrees, the notch closes, if you will. So you still have to create a back cut that is elevated the apex by 1 inch to 2 inches to create this stump shot, if you will, so that the back of the tree lodges on that, keeps motion going forward. This is the notch that I use almost all the time. It's an open face notch. It essentially takes a 45-degree notch and opens up the face to 70 degrees or more. The reason for that is that the tree then gets past 45 all the way to 70 to 90 degrees, which means the tree is on the ground before it creates pressure at the base, and it has more control. It allows the notch to work farther, if you will, as the tree is going versus having it stop at 45 degrees. Now, this would be an open face notch on level ground, and we actually have a nice design feature into the saw that way. When you hold the saw, it literally puts that bend of that blade at about 70 degrees. So all I got to do is hold it in the bend and aim where I'm cutting my notch, and then cut into the tree till I'm about 80% across the face, if you will. So this would show you that you're on level ground, if you will. The nice thing about this as well is you're cutting more down the front of the tree. You're not cutting as far into the tree, and which keeps the cut, if you will, more into the sapwood. Now, if you're looking down through the top of the tree down, this would be the notch that is cut out. You would cut this top cut until you're about 80% of the diameter of the tree, if you will. You don't want to cut to your 100% because that means that that hinge wood is going to be all the way halfway through the tree, if you will. So we want it to stay out front, if you will, out of the heartwood, more into the sapwood, which is the strong living fiber, very, very strong fiber of the tree. So 80% across. That also keeps my hinge more into the sapwood, if you will. So that's your cut. If you were making the open face notch on a hillside, it literally would be just angling that bottom cut downwards so that you match the slope of the terrain so that the notch face closes after it's on the ground down the hillside. Remember this as well, when you're dealing with trees that are leaning backwards and you got to pull them up and over or wedge them over or machinery or rig them over, however you use them to get them to go over top dead center, you must make that notch larger because you could literally, by pulling the tree up, eat up your 45 degrees of notch, and the notch is closed and the tree is vertical. So you really have to have this opened up a lot more so that you can allow the hinge to work after the tree goes over top dead center. So you'd want to have that open this way, very similar to what you got down there. Now the nice thing about this is that you can make this cut now equal or elevated by 1 inch to 2 inches above the apex, which gives you some margin of error. It's a little bit easier to do, can show you outside. It's also a lot more helpful to use that when you're using big trees and making cuts from the back on the big diameter types of trees. That tree now gets all the way down to the ground, the hinge works all the way, the notch face stays open, and everything is good. We have direct control all the way down. Now, we've talked about the hinge. The hinge is the uncut wood behind the notch, if you will. So in my first diagram here, it would be something that looks like in this area here. This would be your uncut wood, because without a hinge, you don't have any control. It doesn't allow the notch to work all the way, the tree all the way down to the ground. So you must leave a certain amount of wood. The calculation for that hinge wood, if you cut from the back, whatever you're doing, you have to leave a certain amount of that. The formula becomes 10% of the DBH. Now, DBH is an acronym for diameter breast height. That's a measurement at 4.5 feet above the ground, because you largely get above the root flare up into what is the measurable part of the tree based on its age and so forth. 10% DBH. So if I have a tree here that's 10 inches wide at 4.5 feet above the ground, 10% of 10 inches is 1.0, 1 inch. So you'd want this to be 1 inch as it is uniform to 80% the length all the way across the back. Now, the traditional way of doing this is to cut from the back until you get up there to your hinge size, chain break, and get into your escape route. We'll talk more about that later. What I propose to you is this. The hinge, to most people, is the most important part of felling a tree. So when you're cutting the tree from the back, you're setting up the hinge last. As opposed to, we talked about those reactive forces. If I try to go through this tree with the top corner, it's going to kick. But if I try to go through with the bottom corner, it'll allow the reactive force of pull on the bottom to go right through the tree. I can then go up and make my hinge, come to the back, and leave a little piece of holding wood here. That gives me added time to look at my crew to judge where they're at or environmental conditions or wind. I then just cut the back piece of that just prior to my escape or planned retreat. And I have a very, very good fell because the hinge is made first, which is the most important part, instead of me cutting from the back to the front. We'll talk about this again. 85% or higher of injury is related to 15 feet to the stump. So if I'm cutting from the back to the front, I'm cutting directly under where I'm at. I have a very, very high incidence of injury. If I cut through the center, make the hinge first, leave a piece, I can extend my retreat, check my crew, check the weather. I can clip that piece and the tree falls very quickly, and I have great control because the tree hinge is set at the perfect size and set right at 10% of the DBH.
All right. Anyone have any questions? Comments?
I've got one about doing that plunge cut.
Mhm.
There are times where I've taken off large limbs that are on the sides of trees from the ground. You know, you've got like some sort of like big silver maple, and you've got like some sort of like 25-inch leaf that comes off and off to the side, and you can have a perfect spot to just lay it on the ground. When you do a plunge cut like that, because it has a chance to barber chair, be very wherewithal of how that saw is going to eat. It wants to sometimes go into, or if you set it up poorly, you could make your notch and basically cut all of your hinge almost instantly if you do it incorrectly. It takes a lot of practice to do before you start doing that. So I wouldn't just start doing it on those leads like I'm talking about. You can easily pinch a saw, you go in there, you cut your hinge by accident too fast because you set it up wrong, or the tree, your saw eats differently than you expected it to. And then all of a sudden you got your big saw pinched in there, in that spot, right in the tree. And that becomes a big hazard. So when they set up things like that, and while we're learning them today, practice on really small stuff first before you start doing any of that kind of stuff, or before you feel like you're comfortable to do it, because there's a high margin, or there's little margin of error for doing those plunge cuts and that kind of stuff.
Yeah. So small trees, unlikely going to be able to do a plunge cut, like doing like even like 7-8 inch diameter trees.
Right. Yeah.
Your bar is going to be too wide for it. Yeah, you're going to need field practice and training. This doesn't constitute as that. This is more of an overview of what our steps are in a felling process. So if you're new to felling, don't take this as, yeah, I'm just going to go out there and start felling trees. Get with your foreperson and more experienced people before you take that on yourself. And yeah, go ahead, Reggie. Maybe no. You're muted.
Yes. Oh, yeah, there we go. But I just wanted to mention, especially with these, when felling and doing these plunge cuts or any of the felling, just make sure these saws are sharp and running correctly so that you don't have any extra distractions on like trying to force it through and stuff. A well sharpened saw is going to be crucial when you do this. So make sure the saw maintenance is done with.
Yep. Thank you, Reggie. Go ahead, Matt.
One thing just to add, just when you're looking at felling, we're looking at the drop zone during your 360 walk around, take into account the shape of the canopy and the structure of the tree. If I have a perfect fell direction, we'll call that 0 degrees, but you've got, a lead going, let's say 37 degrees to the left. If that's towards your fell line, if that doesn't break when it hits the ground, you have to take into account for the shape of that canopy because it could roll once it hits the ground. So just looking at that when we're looking at felling trees too, to make sure that you're taking into account the physics that are going to come into play after that tree is on its way to the floor.
Yeah, great point, especially if you have a lead that's like sticking off the backside of that tree and 180 degrees of your fall line. That whole tree could rotate 90 degrees, and now that super long lead now becomes super wide into your area also. Go ahead, Connor.
Can you guys hear me?
Yeah.
I wanted to just kind of touch on, I don't know if we talked about it, but kind of looking at the spar in general. So say you get down to just a spar wood. I know I had an incident a few years back with Kevo. We were felling just a box elder tree that had a bow or a banana in it. You're felling a tree next to a house, and you think a spar log's just going to sit down, but you got to take into account if there's a bow and you're felling onto like maybe a little harder or firmer ground. There's an opportunity for that bow or that banana to rock, and that log will jump, 3 to 5 feet to the side if it has to, depending on which way you're felling. So just if in that case, I know one way that I go at that is, say I've got a bow of 15, 20 feet up, I'm going to keep going, chunking down logs just past that bow to take that bow out. Or else if I've got an adjacent tree, like you said before, tying a butt tie can mitigate some of that jump to the side that you don't want it to jump. Just kind of a little bit thing to add.
Yep. Yeah. Take those. Yeah. Bows and trees can do very unpredictable things, taking them down. Anything else? Any near misses out there anyone wants to talk about in the last week?
Matt, you had some awesome near miss submissions about crawler trailer stuff. Could you talk about that quick?
Just making sure when you're packing the thing up, just little things that you can miss if you don't do your 360 walk around before you leave a site and go to the next one, even if it's close. We had a near miss good catch for the outrigger pads. They were in the basket, but the carabiner wasn't secured. And then also there was another one where just especially right now, this time of year, just with the terrain, sometimes it's dirt, sometimes it's mud, sometimes it's class 5 driveways, making sure that your trailer and your tracks, if you're, driving across that, having to use the driveway to turn, you can get stuff caught up in those tracks. So make sure that you're trying to get as much of that out, because that could be a potential hazard as you're driving down the road and you got rocks and other debris that could come off your trailer when you're driving.
Mm-hmm. You guys also had that one with the you guys had your cones, you're all set up, but then somebody, while you were either undoing or strapping down the crawler, you had that car that came by just flying past you guys.
Yeah, so we showed up on a property. We were all parked on one side of the road, so we didn't bottleneck. But during our job, there's construction on a house across the street. They all showed up and kind of bottlenecked that side of the road. And as we were strapping out the trailer, just making sure you give yourself a little bit of room to be inside of your cone line in between your truck and your trailer. While I was strapping it down, I mean, the end of this road was a cul-de-sac, and I was strapping the trailer down. I was walking from the rear tie end to the front of the trailer to ratchet that side down, and someone smoked in between that bottleneck at probably 30 miles an hour or so. And had I not had the room to be inside of my cone line, I would have absolutely gotten smoked as they came through there. So just, keeping your head on a swivel, making sure that you have the room to be safe.
Yep. Yeah, I want to bring it back to Matt's thing about cleaning off trailers. Same thing with bucket trucks. I noticed they're getting a little dirty. Take a blower to them before you guys go out today. I know the south side, I don't know about the west, but I know the south side ones were getting a little dirty, had them blow them off. Blow those off because those sticks can become projectiles, and that could actually be seen as an unsecured load for DOT. And the DOT is out in full force right now with weight restrictions going on, and they're money hungry. So they'll get you for anything that's unsecure. Reggie, you got another thing?
Yes. Well, do you have that picture I sent with from that clam pickup yesterday that had all
I
the
do. You want me to?
stickles and stuff?
Yeah.
Yeah.
Want me to bring that up?
Yes, please, because this is what we don't want to do.
Okay.
Or without giving a heads up. Giving a heads up to the clam guy.
Share my full screen. Click that out. We got too many things open. All right, 2 seconds. There we go. There.
Okay, so I pull up, and right away I already see like so many safety hazards if I were to set up close to this pile and be able to get it. From this angle, you got the fire hydrant right there. That ash that's on the road, it has a low hanging limb, which I wouldn't be able to reach underneath there anyway to get that pile up on the wall, or anybody wouldn't be able to do that. Now, if we go to the second picture, it's from a different angle, and you can see the bus stop sign there too. So it's right on the corner where there's a bus stop, there's a stop sign, and there's that hill there. And in order for a clam driver, and the trailer definitely wouldn't be able to get it, in order for a clam driver to get that, he's got to park European style right in front of that stop sign, and then put cones out. I did not pick it up because I didn't want anyone running that stop sign and hitting someone else, or having the bus come while I was loading. So if you can, guys, let's keep a good eye where we're putting these piles, and just think realistically if the clam's going to be able to efficiently get that out of there without hand dragging it all to the street or across the street or whatnot. I don't know if you got anything to add to that, Wes?
No, I just want where would be a good spot location for this clam pile?
Well, it would
You
have
want me to
been
go to the other
over.
picture?
Yes, please.
I
So
can kind of
now
touch on
maybe
this because I was the one that made this pile. And kind of give
All
our
right, go ahead.
explanation. Obviously, I can understand what you're saying. So on that picture, if you look to the left of the fire hydrant right there, that is where we had the bucket placed. And just ahead of it, you can see the steps. Past that, there's a line of cars. We were not able to stage any further up because of those cars. And the reason we didn't stage right underneath the bucket is because that was where the bucket was constantly dropping. So we're trying to stay out of our bucket's drop zone. And with this pile placement, yeah, I understand that it should have been known that, or it should have been let you know that there's a pile on the top of the retaining wall. Yeah, that was looked over by my crew, but this was the maximum amount of staging space on a busy road that we felt we didn't want to leave any pile leaning into the road with cars driving by, especially on that stop sign side. I don't know if you drove past it, but that's a pretty heavily used road. So we were trying to keep that pile tucked off the road as much as possible without taking up any sidewalk space or any street space. But the reason we didn't place it kind of right out front by that fire hydrant is because we were constantly dropping brush right there, and we were trying to stay out of our drop zone as much as possible while staying efficient. But hindsight 2020, we could have waited. It'll take a little bit more time, but waited till the bucket was done, and then obviously went in and cleaned up what the bucket had been doing, and then made the pile on that safer side. But that's just something that we'll have to look forward to or look out for in the future.
And I'll add to that too quick, because we split jobs at the end, and so Connor was running the job and then I ran it at the end. So I ended up sending the clam in, and it's just something that I overlooked at the time too. We talked about where we were going to put it, but I could have made a note about that. So it's on me as well.
Okay. And even if it would have been up high on the hill in front of that birch back there, I would have still had a better chance of reaching it.
That was like I said, that was the drop zone. Just to point out, that was where we were working with that birch. It was a heavily dirty birch, so that was the drop zone.
Okay. Yeah, so just no from the over there with the intent of just ground. It was a wasted trip because then I got there and saw what was there. So just a heads up, guys.
Could you not reach that from that distance? Was that too far of a reach for the clam? That's just even if you did have to park Euro, was that still too far to reach?
No, I can reach it. We're gonna go back over there this morning. I'm gonna go back with the spotter, but from the hydrant side, no way. From the stop sign side, yes. It's just that I'm gonna need a spotter just because that bus stops right there, and I don't want anybody running blowing that sign.
Gotcha. Okay.
Thanks, guys.
And then Ryan, did you have a comment? Saw your hand was up.
Yeah, if there's any question that we have, or if it's like a maybe, if we just took a quick picture from like maybe in one or two angles, would that be helpful for you guys?
Yes, pictures are very nice. And then we
Yeah.
know what we're working with, you know? And then we can say, oh, no, that's not going to work or whatever. But yeah, pictures would be awesome.
Yeah,
Okay.
I like doing that. Ryan, do you have the clam operators' phone numbers?
I have Sean's, and that might be it.
Yep. Get Reggie's also, and maybe Kevin Dudley. Because I always, if I'm in like certain situations where I'm working on a busy street or something, I like to give the clam operators a call, give them a heads up, see if they know the area, like especially in Minneapolis, it's Cedar Lake Road, which is a super, super busy area. And someone might be staying behind just a spot for them, you know, if you can get them on site right after the job. So it's always nice to have their phone numbers, give them a call, you know, see what their thoughts are. Because a lot of times these clam operators know these areas very well, been to these houses before and dealt with this stuff. All right. Anything else? We're kind of over time. Yeah, what's up?
One more thing with clam and trailer loads and measuring these piles, okay? I did type up the thing, and if we could just stay away from the 16th of a load stuff, the 1/32nd of a load, because that could vary from tech to tech. Let's keep it 2 yards, and a good way to kind of judge the yards is if it looks like it can fit in the back of a pickup truck, that's 2 yards, and that's something to go by, you know, go with there. The clam is 30 yards full. That truck holds 30 yards of debris, so then you can get into, you know, if it's more than 8 yards or whatnot, you can, or if it's 8 yards, just say, okay, it's going to be a quarter of a clam, you know, half of a clam. Let's keep it like that so we can kind of get the language down so everyone's almost aligned with it. It's not going to be perfect, but it gives us a better idea. If we're in an area and we got enough space for that quarter, then now we can just swing through there. If we show up to a 16th of a load, hell, that could be an arm load or that could be, you know, 3 yards depending on the tech. And as far as the trailer, that holds 10 yards. So if it's a full, if you know it's about 10 yards, it's a full trailer. And then let's use the quarters and the half. And mostly with the trailers, if we can stick with the yardage, that's going to help us out a lot. And that's just so we can get a basic range that every can doesn't see how I'm thinking good. All pretty much appreciated on.
Did anybody get that last part?
Nope. No.
No,
Oh, I'll write that in an email. Write it up in an email, Reggie. Your
Yeah,
internet
we were
connection's
losing you,
poor.
Reg. We couldn't. Yeah.
Can we for some people, I know for me for sure, I'm not too familiar with yards. I've always done like the 1/6 load type of thing. Can we get like a comparison? I don't know. It's like, what does 5 yards look like? What is, like, you know, because when I'm out there, I'm not too familiar with laying out or saying, you know, or presenting yards. Can we get like some sort of like, this is how big you know, 10 yards looks like, or 20 yards looks like? Can we get something like that? So then that's sent in an email, you know, we can look at that and be like, okay, this is relatively about this, so that's going to be 5 yards.
Do you want to take that on, Connor?
Oh, sure, yeah.
I don't know, like you could use like car sizes, you know, because like a
yeah,
yard,
that's what I was
a cubic
thinking
yard
about,
is
like,
3
you
feet
know,
by 3 feet by 3 feet, you know. So if you want to do the math,
Which is a
yeah. So
yeah, I can take that on.
just take different like known objects, and if you want to kind of get the size of that, that'd be great.
yeah, I'll take it on and I'll have it done by next week.
All right, sounds good, man.
Oh,
How
yeah.
many tires does an elephant?
Say again, Ryan?
No, I was just kidding.
Oh, okay, I couldn't hear you. And then as far as today, because I've got everybody here, I can start mobilizing people. So I'm going to share my screen with.
Yep.
And here we go.
Can you? Okay, good.
So please work. There we go. We've got some bonus people today. We've got both Corey and Brandon that's going to be out with us as well. So the way I've got it set up is going to be Connor, Nate, Evan, Luke, and I'll talk to Brando to see he does have a meeting today, but I want to make sure he can be float a little bit more. But those four for sure for your guys' day, Connor, Orchard Ladder, Crawler, 2 jobs. And then for Tom and group, it'd be Tom, Cam, Micah, and Corey. And then that way for you guys today, you've got 2 jobs here, smaller ones, $200 and $300, but then your last one is pretty big in St. Louis Park. And then for Emma, I've got it set up, no equipment, take bucket just in case. I'm gonna have it be Emma, Matt, Lester, and Grace. And then Matt, if you could take R2, just in case if we end up needing to use the bucket on that site. And then for Ryan, you guys have Crawler, it'd be Ryan, Ian, Thomas, and RJ with Crawler. 3 jobs, a little bit more even on jobs, but you're in St. Louis Park, Golden Valley area for Ben Johnson. And then it'd be Chip Truck and SLP once again. For the most part, people are kind of in that area of like St. Louis Park. Connor, you are out a little bit further in Eden Prairie and Hopkins, but Emma, Minneapolis, where we could have a clam pick it up. But nothing looks too crazy besides this one. Yeah, what's up?
Is there, could we put like who is driving what for like the clam or the trailer on this sheet, or is that somewhere else that's easy to see? So like if we did know that like the trailer is picking up our job, that we could text or call that person specifically, just so we know every day who's doing what.
Yeah, yep. I'll have to just talk to Sean in the morning and let you guys know. Sometimes Sean and Reggie, they switch off on who is doing what. Most of the time, Reg, you were running clam, and most of the time Sean is in trailer, would you say?
This week, yes. Like
Okay.
it was out. Yeah.
Gotcha.
And I think he's gonna finish this week out, and then next week, because I don't want we don't want to burn one guy out on trailer stuff. So we've been kind of switching. So next week I'll probably be back in the trailer.
Got it.
We'll let you know. We'll let you know, Carl, and then you can let everybody else know.
Yep. Okay. And I'll talk to Sean too, so that he knows the situation on that, or you can, and he can talk to me too. So we can start having bubble 1 come in and mobilizing and getting ready, as well as SLP, and then we will have bubble 2 in here in about 20 minutes. So thank you guys.
Have a great day, everybody.
Yeah.
Yeah, have a good
We'll
day.
see ya.
Supposed to get up to